All right, a quick rundown of section 4.4, polynomial and rational inequalities. So you're going to take what we were doing with polynomials and rational functions, and we're going to use that. So the idea here is that if necessary, we factor, because we know that factored form lets us find things easy. Second thing we're going to do is find zeros, and when we get to rational inequalities, we're also going to find vertical asymptotes. And then we're going to set up a sign chart to figure out where answers are, and then we're going to test the intervals. So we did inequalities with quadratics. We put the x-intercepts on a number line. We tested positive and negative stuff, and that's what we're going to do here. We're just going to have, more times than not, more than 2 x-intercepts. So let's look at a couple examples. First example, x cubed minus 4x. We're looking for when that is greater than or equal to 0. So we always want one side to be 0. That's how we're going to be able to do these nicely. You got to factor things first. This is x squared minus 4. X squared minus 4 factors to x plus 2 and x minus 2. So now that we have this polynomial in factored form, we think to ourselves, where are the zeros? They would be at 0, -2, and 2. So if we think about a graph, this polynomial is only going to cross the x-axis in those places. Something like this. The idea here is that the graph will be above 0 and below 0, and it'll only change when it crosses the x-axis. So what we're going to do is we're going to take these x-intercepts, put them on a number line, put our zeros on the number line, and we're going to test each of these intervals. So you're going to pick a point in each interval. We're going to plug it back into, I'm going to plug it back into the factored form. We're going to see if it's positive or negative because we want the positive numbers. I guess I should also say that since we're allowed to equal 0, I'm actually going to put some closed circles because each of these points is what makes it 0, so they need to be included in the answer. So if we tested -3, for instance, -3 times -3 plus 2 times -3 minus 2, I only like to think about positives and negatives. -3, that's negative. -3, that makes that negative. -3, that makes that negative. So negative times a negative times a negative is a negative result. You could actually figure out what the result is. -3 times -1 is 3 times -5 is -15. So you could find the result, but you only care about the sign. Pick a number between -2 and 0. How about -1? That would be negative. This group, when we plugged in -1, would be positive. This group, when we plugged in -1, would be negative. Negative times a positive times a negative would be a positive. The two negatives would make a positive. We're going to test 1. How about between 0 and 1? Positive, positive, and negative. Multiplying those three things, we'd get a negative result. Something bigger than 2, like 3, for instance. Positive, positive, positive. Multiplying all positive numbers gives a positive result. And since we want to be greater than or equal to 0, we want the positive outputs. So our answer, included endpoints or equal to stuff, you need brackets. -2 to 0, and then it's also from 2, bracket 2 to infinity. Infinities always get parentheses, so that's the only place where there's a parenthesis. Let's do 2 more, and then we'll get to rationals. So another example, I guess I should say, if I write it down and you want to try it before I do it, please just pause and try it yourself. I'm going to do 2x to the 4th plus 3x to the 3rd, and I want that less than 5x squared. So for a problem like this, we want 0 on one side because we need to use the zeros. So we would rewrite this as 2x to the 4th plus 3x to the 3rd minus 5x squared is less than 0. We can factor out an x squared out of everybody. 2x squared plus 3x minus 5. I don't know how you like to factor quadratics with a leading coefficient other than 1. I'm a fan of guessing and checking when there's primes. So 2x squared means that one has to be 2x and the other has to be x. 5 is also a prime number, so these have to be 1s and 5s, and then we just have to figure out which is which. That's a plus 5, that's a minus 1. 5x, negative 2x gives us a positive 3x. But anyway, you factor how you would like. What are our zeros? From this we get 0, from this we get negative 5 halves, from this we get 1. Number line, negative 5 halves, 0, 1. Since we're not allowed to equal 0, we're not allowed to include endpoints. So I'm going to put some open circles. That's going to use some parentheses. Then we're going to test our intervals. What is that? That's negative 2.5. So I'll do negative 3. I will do negative 1. I will do a half. And I will do 2. So negative 3. Negative 3 squared is positive. That would be negative. That would be negative. That's going to end up being a positive output. Negative 1. That would be positive. That would be positive. That would be negative. Negative output. 1/2. Positive, positive, negative, negative output. Because positive times negative is negative. And then 2. Positive, positive, positive. Multiplying positive numbers gives a positive result. We want to be less than 0. So we're going to take our negative intervals. We cannot include endpoints though. So parentheses, negative 5 over 2 comma 0. And we can't include 0, so we actually have to write it like this. And then 0 to 1, where we have parentheses around the 0. This says all numbers from negative 5 halves to 1, not including 0, not including the endpoints. All right, one more. Last polynomial example. I'll give it to you already in factored form. X plus 3 times x minus 4 squared times x plus 1 squared times x minus 2 is greater than or equal to 0. So our zeros are negative 3, 4, negative 1, 2. We're going to put those on a number line. We're going to test intervals. We're going to see where it's greater than or equal to 0. Negative 3, negative 1, 2, 4. We're allowed to be equal to 0, so we include endpoints. Give some closed circles, which means brackets are on the way. Test, negative 4. Negative. Anything squared is positive, anything squared is positive. So negative times positive times positive times negative. That gives us a positive output. Negative 2. Positive. Always positive, always positive. Negative. 3 positives times a negative is a negative output. I'd test 0 here. Positive, always positive, always positive. Negative. Negative output, because a bunch of positives times a negative will be a negative. 3. Positive, always positive, always positive, positive. All positive numbers multiplied gives a positive result. Same thing with 5. Positive, 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 positive. All positive. So here, we want to be greater than or equal to 0, so we have here, here, and here, but don't forget we want our endpoints. So we go from negative infinity to negative 3. Negative 3 gets a bracket. Negative infinity gets parentheses because parentheses are always with infinities. We have negative, negative, but we have to include this endpoint. There's like a little bounce point here in the middle. So we're just going to put brackets around the number negative 1. And then we include from 2 to 4, but we include 4 in the middle of these two positive things, so we can just write and go over towards infinity to kind of grab everything. Because everything is positive or 0. Past 2 that way. Now, the nice thing about this is that we're not doing anything different for rational functions. There's just a little bit of a difference you have to worry about when working with the asymptotes. So let's start with our first rational function, x plus 2 over x minus 4 is less than or equal to 0. So for these, we're going to find zeros, but we're also going to find vertical asymptotes. So the 0 is negative 2. The vertical asymptote would be at x equals 4. You're going to take both of these numbers, put it on a number line. Now, here's the thing that is really confusing about these. We want less than or equal to 0. So we include the 0 because that's a number that makes it equal to 0. So that's okay. But 4, we do not include. We never include vertical asymptote numbers because they're not in the domain. You're not allowed to plug in 4. So you can't include it in any answer that you get. It wouldn't make sense. So any vertical asymptote number, even if it has the or equal, has to have an open circle. We do not include that number. And then we test our intervals. Test -3. Negative divided by a negative is positive. Test 0. Positive divided by a negative is negative. Test 5. Positive divided by a positive is positive. We want less than or equal to 0, so we get that point and we get this negative. So our answer is bracket -2 to 4 parentheses because we do not include 4. All right, let us do 2 more and that'll be it for this. Let's do example. You can see it. Let's move this up though. We're going to do 5x minus 1 squared times x plus 3 all over x minus 4 times x is greater than or equal to 0. So we find our zeros. It's already factored. 1/5, -3. Vertical asymptotes, 4 and 0. All of these numbers go on the number line. -3 is the smallest, and then 0, and then 1/5, and then 4. We're allowed to equal 0, so we're allowed to be these points. Vertical asymptotes are not in the domain, so they cannot be included regardless. Then test your intervals. If you test -4, always positive, negative, negative, negative. So negative on top, positive on bottom, negative right there. Test -1, always positive, positive, negative, negative. So positive times positive is positive, negative times negative is positive. Positive divided by positive. Positive! And then going on, I'm just going to say the rest. This will be negative, this will be negative, this will be positive. So we want to be greater than or equal to 0. So we're going to take our positives and our inclusions. So we're going to do -3 to 0. -3 with a bracket, 0 with a parenthesis. We're going to include the point 1/5 because that's where it's equal to 0. And then we're positive past 4. So parentheses 4 to infinity. All right, one more and that'll be it for this one. X plus 5, x minus 3, 2 minus x all over x squared minus 4 is greater than 0. So we got to factor the bottom. X plus 5, x minus 3, 2 minus x over x minus 2x plus 2, and that's greater than 0. So our zeros. Well, I guess first of all we should say that this thing right here we can rewrite as negative x minus 2. So there would be a hole at 2. Guess I forgot to add that to our list. There's a hole at 2. Zeros would be -5 and 3. Vertical asymptotes would just be -2 since there's a hole at 2. Holes in vertical asymptotes always get open circles. -5, -2, 2, 3. But in this case, since we're not allowed to equal 0, everybody gets open circles. We cannot include any of these numbers. When you test your intervals, you get plus, minus, I'm sorry, I'm going quickly through this, plus, plus, and minus. So since we want to be greater than 0, we're going to add in all of those intervals. -infinity to -5, union with -2 to 2, union with 2 to 3. And that is a quick rundown of polynomial and rational inequalities.